So 12 times 8. So 8 is the most dito, molecules, then multiply by the molecular weight. Okay. Then plus your 18 man, this one. Okay. Then multiply it by 1. So again, kilogram per kilogram mole. Okay, so divide that 1. So we have the product of, so we have the quotient, sorry, 1505. So that will be the unit is kilogram of air divided by the kilogram of fuel. Okay. So this is now your stoichiometric uh, sorry, but this is the air fuel ratio for our ideal stoichiometric. So this is our air fuel ratio ideal, no? So that is without an excess air. Now let's go for the air fuel ratio with excess air. Now for letter B, so we have your air fuel ratio. Okay. For our air fuel ratio with excess air, so we have, that will be this equation AF, air fuel ratio. So that will be mass of air, then mass of fuel usually. Okay. So this is equal to air fuel ratio stoichiometric. Okay. So stoichiometric, ito yung kanina kinocompute natin dito. Then 1 plus your excess air, or let's say E air. Okay. So ito yung ano, we use E air to express as an excess air. So substitute natin, so yung value ng stoichiometric natin dito lately, na-compute natin kanina. So what we have na-compute natin kanina, that is 15.05. So we have 15.05. So this is kilogram of air divided by the kilogram of fuel. So I'm going to multiply that 1 plus your excess air. So sa problem, stating doon, so we have how many percent? So it's burned with 50% excess air. So I'm going to use that one. So that will be plus 0.5. Okay. So using your calculator, we have now your air fuel ratio. So distribute natin doon using our calculator. So we have the air fuel ratio, which is equal now to 22.7 kilogram of air, kilogram of fuel. So take note of the units na ginamit natin, that is a ratio. Okay, yung air fuel ratio, kaya tinawag na air fuel ratio because it's a ratio of air and fuel. Okay. Now, going back to the question for our letter B and letter C. So if the engine has a brake-specific fuel consumption of 0.203 kilogram of fuel kilowatt-hour, and it develops 200 horsepower at 2000 RPM. So what is the volume of air at ambient condition at 1 bar and 30 degrees Celsius? Okay. So going back to sa questions doon. Okay, so by means of your airflow rate. So let's compute your the equation for airflow rate. So I'm gonna write this one for air volume flow rate. Now we have your PBMRT, your PA, you have your BA. So that will be M time mass of air, R of air, then temperature of air. Okay, so to get the volume flow rate, we have volume of air. We are writing an equation, okay, divided by the pressure of air. Now, what we have for your mass of air, or divided by your mass of your fuel, is simply equal to your air fuel ratio, no? Then we'll try to get the value of mass of air since yung R of air is already constant and it is given, and we have the temperature already being given, and we have the pressure usually in the intake, so that will be the atmospheric pressure. Now, what we don't have is how much is the mass of air. So we're going to rewrite our equation to get the mass of air. So we have your stoichiometric na rin doon kanina. So we have already the mass of air, mass of fuel to get the mass of air. So to get the mass of air, so we're going to rewrite our equation. So air fuel ratio times your mass of fuel. So which is given sa problem which have 0.206 kilogram of fuel per kilowatt hour and the velocity 200 HP of horsepower. So we have that one. Then multiply it by the brake horsepower, which is 200 horsepower, okay, at 2000 RPM. Okay, so I'm going to multiply this one by brake horsepower. So we have your mass of air now is equal to air fuel ratio, which is 22. Okay, 22.7 kilogram of air divided by the kilogram of fuel. So I'm gonna multiply this one by the mass of fuel, which is given already the problem. So that will be 0.203. Okay, so that will be kilogram of fuel in units niya, take note, divided by all over by kilowatt hour. So take note yung unit, no? So observe that one. Then I'm going to divide it by the brake horsepower, multiply by the brake horsepower. So that will be 200 horsepower. We have 200 HP. So para mag-cancel out, so we need to convert that one, yung kilowatt to horsepower. So we have the conversion. Take note yung conversion ng horsepower to HP. Okay. So you should memorize this on the conversion. This is a basic conversion. So we have 0.46 kilowatt. So that will be 1 horsepower. Okay. Then we have, so we need to compute also yung hour. So we need to convert that one to seconds. So we have 1 hour is equal to 3,600 seconds. So cancel natin ito, mga dapat ma-cancel dito. So we have to cancel that one. So horsepower is cancelled, kilowatt is cancelled. Okay, so what is left now is cancel din pala ito, kilogram of fuel and kilogram of fuel. So take note, so mapapansin nyo ang naiwan which is ng kilogram of air. Okay, so napakalaking bagay that we must always know, no? Plus, we must always know what is the unit ng ano natin, ng mga properties, no? So, it is one way of checking our solution kung malapit na ba tayo or naliligaw tayo sa solution natin. So, usually, yan, pag nag-iba ang values, iba ang unit mo. So, there's something wrong with your equation. So, take note of that one. So, we have value of that one is now 0.19. So, this is kilogram per second. Okay, so meron na tayong mass of air. Now, to get the volume flow rate, so we just simply substitute this one to our equation dito. So, to get the volume of air, so we have volume of air, so we substitute 0.19. That would be kilogram per second. So, I'm going to multiply this one by the R of air. So, we have 287. So, take note, yung constant palagi ng R. So, you must always, remember or memorize this one. So, because you will be needing this one in the board exam. So, hindi naman siya i-give doon sa problem. So, you have to memorize the value. So, we have here now 287. So, this is Newton kilogram. We have your Kelvin. Okay, take note. Then also the temperature. So, take note class, no, every lahat ng ng problems which is involving yung thermodynamics. So, palagi ang pressure and temperature are always on the absolute values ang ginagamit natin. So, we don't need. So, kung gumamit kayo ng hindi absolute values on temperature at pressure, which is yung given sa problem is degrees Celsius lang for the temperature and also degrees Fahrenheit. So, yun lang ginamit ninyo. Eventually, there will be a problem doon sa final answer nyo. So, eventually, magkakamali kayo. So, always convert. So, take note of that one. So, always convert from absolute values lahat ng temperature and pressure. So, it was always required to convert that one. So, minsan kasi doon ang nagkakamali lahat ng mga student. Even though I was a student same as you. So, din ako nagkakamali. So, just only reminding you. So, para may iwasan yung mistakes. Okay. So, I'm going to convert this one to the temperature. So, we have 32 degrees Celsius plus 273 for the Kelvin. So, usually, that will be, okay. So, divide that one by the pressure. So, we have 1 bar, no? Yung pressure natin 1 bar. So, I'm going to convert that one. So, 1 bar is, so that will be 100,000 yung conversion. So, we have 100,000 Newton per square meter. Okay. So, that will be divided by 1 bar. So, I'm gonna cancel that one. Yung units. So, take note, cancellations of units. Importante again. Okay, so we have the 1 bar. Then, canceling kilogram. Cancel that one. Kelvin will be cancelled out. Our Newton is cancelled out. So, we have square meter. So, may one na lang. We have the units of cubic meter. So, take note, flow rate is always volume flow rate. So, that is always in cubic. Okay. Now, in pressure, that is always your Newton per square meter. So, that will be the force per square area. So, take, dividing yung value natin dito. So, we have now the volume of air, which is 0.161. So, we have cubic meter per second. Okay. So, that will be the solution to the problem. So, let's have a recap ng ginawa natin. Solution. Okay. Let's have a quick overview of that one. So, from here, from the problem, no? So, we have your octane, which is C880, H18 burn, 50% excess air. So, okay, so what will be the stoichiometric ratio, ideal, and air fuel ratio with excess air? And we have C if the engine has a brake-specific fuel consumption of 0.203 kilogram, where fuel is 0.203 kilogram of fuel per kilowatt of power, and develops a 200 horsepower at 2000 RPM. So, what is the volume of air at ambient condition at 1 bar that is required to the combustion? Okay, so again, writing our fuels of combustion. So we have your fuel plus your air, and we have your product again. So rewriting that one. So take note, ito yung palaging for liquid fuel. So this is for without excess air. So that will be C8H18. So you have A times the air, which is O2 time plus 3.76 into, and we have your B, we have your CO2 plus C, H2O times A, 3.76 of nitrogen. Now, we do mass balance, we get the value of your B, C, and A. Okay. Then, rewriting the equation, substitute natin yung mga values ng A, B, C. So, we have now the fuel plus air and the product, okay, of the combustion. So this is ideal again, take note. Now for the ideal stoichiometric, so that will be mass of air, mass of fuel, okay. So this is equal to the moles of air times the molecular weight of air. So we have that value. Then we have your moles of fuel divided by moles of fuel, then molecular weight of fuel. So finally, we have 15.05. That will be the kilogram of air, kilogram of fuel. Then we have for letter B. So what will be the air fuel ratio with excess air? So take note of also this equation, no? So for the actual air fuel ratio, that will be equal to stoichiometric air fuel ratio times 1 plus the excess air. So later on, we'll be talking that one, how to rewrite an equation with excess air. So this is now the air fuel ratio. This is a shortcut that is usually done with plus excess air. Now, substituting yung value from dito in here. So we have now the actual air fuel ratio, which is 22.7 kilogram of air, kilogram of fuel. So take note, yung units, no, ng air fuel ratio, ganito yan palagi. It is the ratio of air and fuel. So that will be like kilogram of air, kilogram of fuel. Now, for the question at letter B, so what will be the volume flow rate required in the combustion? Volume flow rate. No? So when we say volume flow rate, that is cubic units per second. Okay? Ang unit niya palagi. Then, by means of your PBMRT, since we think that the behavior is ideal gas. Okay. Then, rewriting our air fuel ratio to mass of air is equal to air fuel ratio times mass of fuel times the brake power ng engine. So take note, so sometimes kasi if you know the units cancellation, so malaking bagay siya katulad ng ginawa ko nito. We've been able to cancel out in units and attain the mass of air. So by means of substituting ng tawag dito ng value by means of cancellation. Take note, ang importante rin, you must know also the conversion. So basic sa mechanical engineering, the unit conversion of watts to horsepower. Okay, so don't forget that one. So we're able to cancel that one. So we have now the mass of air, which is 0.19 kilogram per second. Then we substitute this one to the equation. So from your volume of air, okay? So take note, you must also memorize the value of R of air. So very important that one, okay? So, and also the conversion from 1 bar to 100,000 Newton per square meter. So that's the conversion. So kung wala kayong conversion, if you go to the board exam, if you don't know what is the conversion, if you know how to solve the problem, so useless pa rin. So sayang ang points. Okay. Well, anyway, so substituting the value, so we have now the values of your volume of air, which is 0.61 cubic meter per second. So mapansin nyo, we cancel out ang units, then we arrive yung volume unit. So take note, volume flow rate, cubic units, no? Per time ang palaging value niya. So please always remember that one. So it is one way to check yung solution nyo is tama or mali. Okay? So we can later on we have another problem for this one. Okay. That's it. Thank you.